Good afternoon. This is our group presentation of conversion of Guiacol to Xylene. This is a process to convert biofuel to fuel in an economically viable process, and it's eco-friendly at the same time. I hope you enjoyed the presentation.
Guaiacol is a natural organic compound, and various organisms biosynthesize it, and is derived from flowering plants and wood, just to put an example. Guaiacol is an organic compound, as I said before, and it's treated as a dangerous waste material, and it costs $600 per ton to treat it in order to dispose it to the environment. When it is not treated and is right away disposed to the environment, it causes serious environmental problems. The possible solutions that we have for the Guaiacol, since it has a high carbon and hydrogen component, is the production of xylene, toluene, and benzene. Just to put an example, the current international cost of xylene is $600 per ton, and toluene is $645 per ton. So along our discussion project, we're going to be talking about the desired and undesired reactions in the process of xylene production. We're going to be presenting some experimental data, and also we're going to be scaling up to a real reactor based on the experimental data. We're going to express some safety concerns related to reactors, and specifically the PBR reactor what we are using. And we're going to be selecting the catalyst, and we're going to be analyzing our results obtained from MATLAB software.
Some primary safety concerns with a PBR reactor or a plug flow reactor such as this one is the event of a thermal runaway. Now, thermal runaways are the event of uncontrolled heating of the unit, in which the heating will subsequently cause the reaction rate to increase exponentially, causing the unit to possibly rupture and endangering the lives of the operational team and personnel within the area. Now, some possible safety precautions and design implementations that could be put into the design would be valves and sensors along the feed tubes into the reactor, which would the sensors would feed information to an advanced modeling software that would model the reaction within the reactor, giving an advanced warning as to the possible event of a thermal runaway, which would trigger an immediate automated cool down of the reactor through sections within the packed bed, and the valves would immediately divert flow away from the reactor and into holding tanks, possibly saving the lives of the operational personnel within the area. Now, in order to be able to model the reactor itself within the MATLAB software, we had to collect a little bit of data from outside sources. Now, the majority of this experimental data has been pulled from the NIST databank with a reference temperature of 25 degrees for both the heat of formation data and the constant heat capacity data. Now, this is the heat of formation data, which will be used to calculate the heat of reaction. The only exceptions within this table are the Guiacol and phenol data points, which had been pulled from independent studies, both at reference temperatures of 25 degrees Celsius. Now, this is the heat capacities, also at a reference temperature of 25 degrees Celsius. And this had been done in order to keep both temperature references constant in the calculation of the heat of reaction. And this would be used in the MATLAB modeling software later on.
So here are listed our desired and undesired reactions. As you can see, in the bio oil that is fed to our reactor, glycol is the active ingredient, and it has to follow through a couple of chain reactions in order to reach our desired reaction, which could also either go towards producing benzene or xylene. And in order to favor the desired reaction, later on we will discuss the implementation of a catalyst. When researching data, laboratory data on this reaction, we were able to find the experimental data used in laboratory or found in laboratory was 10 millimeter long laboratory reactor, and it was fed 0.064 grams per minute. And when scaling up for our industrial sized packed bed reactor, it's needed to be fed 15 kilograms per hour.
As we discussed before, we're going to be selecting our catalyst. And to do so, I'm going to talk about what is a catalyst, which is a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. For this specific application, the studies show that the nickel-based catalysts present the better results. In this case, we analyzed 3 main catalysts, and we analyzed the experimental data, and we came up to the conclusions that this last catalyst is the one we're going to be using in our xylene production, because it has a 97.79% conversion as an experimental data.
The results from our MATLAB code and our energy balances show that we were able to achieve a conversion of 91%, using a weight of 20 kilograms of catalyst. We were able to achieve a flow of 13.65 kilograms per hour of xylene coming out the reactor, and from the side reactions, we were able to get a feed of 0.3 kilograms hours of water, 0.3 kilograms hours of metal, 0.65 kilograms hours of benzene, and some unreacted hydrogen in the form of 0.1 kilograms per hour. We can either use these as a side to recycle back into the feed, or use them as as side products. From our energy balances, we also found that the operating temperature of this reactor operates at a temperature of 322 Kelvin, and it levels off at 311 Kelvin.
So to conclude our presentation, the aim of this project was to investigate the feasibility of xylene production through the synthesis of Guiacol. Through our results, we were able to find that being able to achieve the 91% conversion rate gives this process a promising outlook in being able to be implemented in the industrial setting. This is especially important given that it is currently sourced mainly through crude oil, and in the given age where society is trying to transition from fossil fuels to renewable energy, this is extremely important in order to also meet the demand of xylene. Thank you for your time today, and this concludes our presentation.